So for this one is a perfect example where you can memorize a bunch of different formulas, or if you understand just a few simple things, then the other formulas just kind of fall out naturally. This one says the topic name is intersections and conditional probability. Um, and the problem stated says, suppose that a certain college class contains 14 or 41 students. Of these, that means of these 41 students, 16 are juniors, 26 are social science majors, and 7 are neither. A student is selected at random from the class. What is the probability that a student is both a junior and a social science major? So important to note as you're reading this question, this is not. There's some overlap between these categories. In other words, 16 are juniors, 26 are social science majors. It doesn't necessarily mean those groups are separate. In other words, it's possible to have some social science majors who are juniors and some juniors who are social science majors. So when you look at this, that's an important thing to note at the beginning. Now it says, what is the probability that a student is both a junior and a social science major? So if I let being a junior be event A, and I let being a social science major be event B, this question really boils down to what's the probability of A and B, or intersect with B. So in other words, that's the notation we could use here. Now, when you think about the addition rule for probability that we've seen before, we had this. Probability of A union B is probability of A plus probability of B, and then you have to subtract that intersection, A and B. And the reason for that is, I think we did this in another video, but I'll do it one more time here. Think about Venn diagrams for a minute, and it helps you understand this. If you think about A, so probability of A, that's anywhere inside the A circle. And if I think about B, that's anywhere inside the B circle. And the reason that you have to subtract this intersection is by the shading that I just did there. Notice that the intersection actually got shaded twice. So if we just add them, A and B added together, you would have actually used that intersection portion, and I'm talking about this right here, that intersection portion, you would have shaded it twice. So by subtracting it once, that takes care of that duplicate. So you use that same formula now, and you can rearrange it. There we go, get rid of that. And if you do a little algebra on this and add this over to this side and subtract the union over to this side, you get that the probability of A intersect B is almost the same thing. Probability of A plus probability of B minus the union. So minus the probability of A union B. And so that's what we're going to use here to answer part A. And so you look at this and say, I'll just write underneath here to make it kind of stay a little bit concise. You look at this and say, oops, one click too many. A is being a junior, so that's 16 out of 41. Plus probability of B, that's social science major, so that's 26 out of 41. And then I need to know the probability of union, but it says 7 are neither. Think about Venn diagrams for a minute. That means 7 is outside here. And so the complement of that, thinking about what you know about complements, what that means is the probability of A union B complement, that's a notation we use for the complement, is that 7 out of 41. So then that tells us the probability of A union B without the complement, in other words, by itself, is you just subtract that. So as in 1 minus 7 over 41. And so that turns out to be 34 out of 41. So that's what we subtract here, minus 34 out of 41. And then do a little arithmetic there. And 16 plus 26 minus 34, that's 8 out of 41. And it doesn't tell us to do that as a decimal, so that's going to be the final answer there for part A, is 8 out of 41. Part B is a similar thing. We're going to manipulate another formula that we've already used, or you can memorize a new one. Part B says, given that the student selected is a social science major, what is the probability that she is also a junior? So, if you remember, we've seen this formula already for how to find the probability of an intersection when you have conditional probabilities. In other words, when the events are dependent. So probability of A intersect with B, we've said, is the probability of A times the probability of B given that A occurred. Or doing that in another way, with you can do either letter. You can say that's also the same thing as the probability of B times the probability of A given that B occurred. So what we're after here is this conditional probability. So if I want to do it that way, probability of A given B, because that's what we want in this case, based on how we define these letters, and I'll show you what I mean there. We're saying what is the probability given that they're a social science major, so that was our B. What's the probability that they're also a junior? So probability of A being a junior given that B has occurred. So we want probability of A given B, and so that's then defined to be the intersection, probability of A intersect B divided by probability of B. And you get that just by dividing both sides by the probability of B. In other words, dividing that to the other side. Or you can just memorize this formula, that there's the conditional probability formula for A given B. And so to put that into practice here, we already calculated the numerator, the intersection of A and B. So that's 8 out of 41. And the probability of B, we've already seen that. That's the probability that she was a junior. And that was 26 out of 41. And that came from, oops, a little bit too far. So given that the social science was probably the junior, and so, and again, as a reminder, the social science, that was just the probability of B, which we already had, that was the 26 out of 41. So now we're just dividing those fractions, and we need to remember something useful about dividing fractions. That means we go 8 out of 41 times 41 out of 26, as in multiply by the reciprocal. So that's 8 out of 26, which reduces to 4 out of 13. That's supposed to be a 3. I'll fix that. So 4 out of 13 is your final cleaned up answer for the probability of A given B. So we've seen a few formulas. We've talked about how they're related to one another. As you work on these questions, I really encourage students not to memorize them, but to try to understand them so that they make a little bit more sense. And I think you'll find with a little bit of practice, they're not too bad.